Have you ever wondered why you suddenly feel light electric shock even without having a physical contact to electricity, such as live wires or to electrical devices? When you are rubbing your feet on the carpet on your way to touch the doorknob, then you suddenly feel the shock. Or when you are having a walk with your crush, then accidentally you touch each other, then you feel electric shock. But oops, don't assume that you have a spark together. Is it magic? No, it's static electricity. Static electricity means the increase of electric charge on the surface of objects. In this video, I will explain you how static electricity works. But before that, let's have a brief history. Greek philosopher Thales of Miletus made the first account. In his 6th century BC writings, he noted that if amber was rubbed hard enough, small particles of dust will start sticking to it. 300 years later, Theophrastus followed up on Thales' experiments by rubbing various kinds of stone and also observed the power of attraction. But neither of these natural philosophers found a satisfactory explanation of what they saw. Did you know it took almost 2,000 more years before the English word electricity was first coined based on the Latin electricus, meaning like amber? Some of the most famous experiments were conducted by Benjamin Franklin in his quest to understand the underlying mechanism of electricity, which is one of the reasons why his face smiles from the US $100 bill. People quickly recognized electricity's potential usefulness. Let's go back to the main topic. To understand static electricity, we first need to know a bit about the nature of matter. Basically, everything you see around you is made up of something known as atoms, which happens to be the smallest particle of a chemical element that can exist. While everything is made up of atoms, the fact remains that they are too small to be seen by the naked eye. Even smaller than an atom are the particles that make it. A single atom is made of three things: protons, which are positively charged, electrons, which are negatively charged, and neutrons, which are neutral. Most of the times, an atom will remain neutral due to the number of positively charged protons and negatively charged electrons being the same. However, things change when this number gets distributed and doesn't stay equal.